Good job this time. Hello, this is Mr. Bing 205, October 22nd, 2020, Principles of Engineering. This is assignment 2.1.4, problem number 1. My man Cody's here. Chase is here as well. Cody asked me to go over this problem. He asked me a question I didn't understand, so maybe going over this problem will answer that question that I don't understand. Chase, wait till I'm done with this. What did he say? Oh, okay. So I don't even know what they're asking you to find here, but I decided, yeah, I don't care about any of that. I don't care about any of that. The only thing I care about is solving this. You solve this vector problem. And what do you solve for? And the answer is everything. And the answer is everything. And so what this is all about is this vector. This vector is a force vector. I know it's a force because the Newton is a unit of force. And A is just a variable to describe that vector. This is an amount of force in the direction that the force is applied. And you can say this a lot of ways. You could say it's 30 degrees to the east of south. You could say it that way. What is he doing? Go sit down. You don't go back to your old ways. Okay, 30 degrees east of south. You could say that. Or you could say 30, say it again. 30 degrees clockwise from the negative y-axis. So you're right. You could say it a lot of different ways. You could say negative 60 degrees. You could say negative 60 degrees from the positive x-axis. So there's a lot of different things you can say, and I don't really care. We can look at it and we know what it is. What I need to know here is how far does this vector, how far is that vector, let me go bigger here. How far does that vector, there, that's better. How far, and by far, there should be like where's the air quotes? Air quotes for how far. How far does this vector go from the y-axis? And I'm going to call that x, because this is a horizontal distance, and x is the horizontal axis. So the distance of how far this thing goes is x. Well, what about the distance? How far does it go in the down? It goes in the right to an x amount. It goes to the down a y amount. And so we have to figure out how to, these are components. We have to figure out how to solve for these components. This is darn it, this A, I'm going to change it to an F because it's a force. This is a force, and then this is the same force in the y direction, and this is the same force in the x direction. And the way that I've drawn this is a little bit awkward because I need it to be a triangle. So if I need it to be a triangle, how about if I draw it like this, where this is F, and this is F sub x, and this is F sub y. It always needs to be a triangle, a right triangle, with an angle. That angle is usually labeled with a Greek capital theta. We got an F, which we know. We've got a 5 newtons. We've got a theta, which we also know is 30 degrees. We have an F sub x and an F sub y, which we don't know. The F sub x is in the positive direction. And that's what Jess, not Jen, that's what they meant by sense. Remember, Jess, you said, what about sense? That's what they mean by sense. It's in the positive sense. I'm doing more air quotes, by the way. And then this one, F sub y, is in the negative sense. So at this point, you know that this is 5. You don't know what those two are. And you're going to have to use the trig functions. Do you remember, or do you have any idea what the trig functions are? SOHCAHTOA, which is, let me see, how do I write that? Sine, cosine, and tangent. And so, what is so? S, what is that? O over H, so? Is that how you spell so? Ka. Okay, so what she just said, if you're trying to figure out so, S-O-H, ka, C-A-H, toa, T-O-A, and then the O stands for opposite, the H, is that an H? Yeah, the H stands for hypotenuse, the A stands for adjacent, the H stands for hypotenuse, the O stands for opposite, and the A stands for adjacent. And the opposites and adjacents and hypotenuses, what in the world are these things? Hey, Ms. Doobie, I'm recording, but you can participate. She just walked away. She just walked away. I need one. When you find one, if there's a second one, grab it for me. Bye, Miss Doobie. Yes. So katoa. So what this opposite and hypotenuse and adjacent and hypotenuse and opposite and adjacent, what this refers to is the theta angle. The theta angle. Which one is opposite of the theta angle? And that's f of x. Which one is adjacent to the theta angle? That's f sub y. And then which one is the hypotenuse? That's just the regular f. So that's what we mean by opposite, hypotenuse, and adjacent. Opposite, hypotenuse, and adjacent. Opposite, adjacent, and hypotenuse. So the sine, cosine, and tangent is going to help us, if I can do this, if I can slide this up a little bit. The sine, cosine, and tangent, and what it really is the sine of theta equals the opposite over the hypotenuse, and the cosine of theta equals the adjacent over the hypotenuse. And then tangent, I mean, it's also useful. Usually you just need two of these three, and it's the tangent of theta equals the opposite over the adjacent. Now, some of you have learned this, you know it's no big deal. There's one more thing that you probably should put in the back of your mind, which is a squared plus b squared equals c squared, which in this case is f sub x squared plus f sub y squared equals f squared. All right, that's something that you might want to use, and who knows? Well, what I'm always comfortable, most people are most comfortable going to the sine first. So the sine of theta is the sine of 30 degrees. And the opposite of that is the f sub x, which is unknown. And the hypotenuse is the 5 newtons, which is known. So if you're trying to solve for this f sub x, and algebra says what's being divided here just can be multiplied here, well, then you end up with f sub x equals 5 times the sine of theta. And when it comes to trig functions, you really need a scientific calculator to do this. I'm looking at my iPhone SE second generation. Say that again? Oh, she already says 2.5. Plug in a calculator and get 2.5. That's what Jess said. Jess said that. Okay, 2.5 what? It's 2.5 newtons for that one. And then you can then use the cosine if you want. And the cosine of theta, I should have written a 30. The cosine of 30 is equal to the adjacent to the theta, which is f sub y, which we don't know, divided by the hypotenuse, which is the 5 newtons. So again, cosine of theta, so it's going to be 5 times, so f sub y equals 5 times the cosine of theta. And Jess, I bet it's not 2.5 this time.
Yeah, it's like
4.33, that's enough, 4.33 newtons. And so there's our answer for the f sub x and for the f sub y. And I'm going to stop there because I'm tired. And I don't care what else the problem was asking for. That's all I care about. That is solving the vector, so to speak. Yes, Cody, before I stop this. What do you mean? What do you mean we don't have to do that? We don't have to do any of it? I don't care what it says. I don't care what it says. I want you to solve for everything in it. Ignore all the instructions. I want you to sketch this. That's what I want you to sketch. Whatever else they ask you for, ignore. I only want you to solve, yes, you sketch, and then you find whatever's missing. What was missing here were these two components, f sub x and f sub y. Does this make any sense? I should do another one, but I got to stop this recording because it went on too long. You're finding anything that you don't know. The only thing we knew to start was the original force vector and the angle. That's all we knew at first. And so what else could we find? We could find the component in the x direction, that's called a component, and then we could find the component in the y direction, that's called a component. That's as far as I don't know what else we could do. And all the instructions that they're saying to you are just little baby steps. All I want is you to take the problem and find what's missing. And if it doesn't make sense, that's perfect, because we'll just do another one. All right, stopping recording now. Bye.